In this video, we will go over binomial probability. And so with binomial probability, we have two outcomes: win, lose, if you're selected or not selected, heads or tails, or like success and failure. And this right here is the formula, and we will go over two concrete problems. So the probability is equal to, so this right here is a combination where n is the number of total trials and x is number of times for a specific outcome. P is the probability of success for a single event, and Q is the probability of failure for a single event, and N is the number of trials. So we can represent combinations like this, and this is the formula. So it's n factorial divided by parentheses n minus k factorial times k factorial, where k is the number of success and n is the number of total trials. So here's the first problem. If you flip a coin 10 times, what is the probability that you will get exactly 7 heads? And if you want, you can pause the video here and attempt this problem. And so we will use that formula. And so this part right here is the combination. And so we use the formula that we saw in the previous slide. So we get n factorial divided by parentheses n minus k factorial times k factorial. Now, probability of success. So for a coin, it's heads or tails, and we're saying that heads is success, and so there is a 50-50 shot, so 1 divided by 2. Likewise, failure is going to be also 50%, so 1 minus 1/2. Now for this problem, we want to get exactly 7 heads, and so the number of times is going to be 7 for the success, and then the failure would be 3. 10 minus 7. And so let's do this part too. So number of trials. So we put 10 here and 10. Now k is like the number of times we will be successful. We want to get exactly 7 heads. So we put 7, 7. And now with factorials, I can say 10 times 9 times 8 times 7 factorial divided by, this right here is 10 minus 7, so 3 factorial times 7 factorial. And the reason I stopped in the numerator at 7 is because I can cancel this 7 factorial with this 7 factorial. And here we have 1 minus 1/2, which we know is going to be 1/2, and 10 minus 7, which we know will be 3. So the 7 factorial cancels with the 7 factorial, and we get 10 times 9 times 8 divided by 3 factorial, which is 3 times 2 times 1. And so if we clean it up a bit, we would get 10 times 3 times 4 times parentheses 1 divided by 2 raised to 7 times 1/2 raised to 3. And if you use a calculator, you would get 15 divided by 128, or 11.7%. And so this is the first problem. Now for the second problem. Let's say we have an exam. There's 8 questions, and there's a possibility you can choose A, B, C, D. So the exam is multiple choice. And we want to know what is the probability of getting 3 questions correct just by guessing. And we're only going to get 3 questions right. And so if you want to pause the video here and attempt this problem, feel free. Same idea. Now here, n would represent number of trials, and so we have 8 questions. So we would put 8, 8. And we want to get 3 questions correct. So the success would be 3. So 3, 3. And the probability of getting 1 question right just by guessing when we have 4 options would be 1 divided by 4. And we want to get it 3 times. And failure, so there's 4 possibilities, and so we would have a 3/4 chance of failure each time we answer a question, raised to 8 minus 3. And so this is what we get. And so same idea. So 8 times 7 times 6 times 5 factorial. And I'm doing that because 8 minus 3 is 5 factorial. So the 5 factorials would cancel. And then we can expand 3 factorial and get 3 times 2 times 1. And we can simplify a bit. 3 times 2 is 6. 6 divided by 6 cancels. And so we get here 8 times 7. So 56 times 1/4 cubed times 3/4 raised to the 5th. And if you use a calculator, you would get about 20.8%. And that's all we need to do for these types of problems.